Hello guys, welcome back to the channel Mathemagix JEE. In this series of videos, we are going to solve all 250 PYQs of JEE Main January attempt 2025. So we are starting with the chapter Straight Lines and Circles. We are going to discuss all 16 PYQs that have been asked in the January attempt in 2025 from this chapter. So I request you to sit with your pen and paper and try solving each question before seeing the solution. So this is the first question here. It says a circle C of radius 2 lies in the second quadrant and touches both the coordinate axes. Okay. Let R be the radius of a circle that has center at the point 2, 5 and intersects the circle C at exactly 2 points. If the set of all possible values of R is the interval this, then 3 beta minus 2 alpha is equal to what? Okay. So let us first uh, draw the diagram. So here, this is the xy axis and this is the circle C. The center of the circle lies at minus 2 comma 2 because it is of radius 2 units and it is lying in the second quadrant. And there is another circle whose center is at 2 comma 5. So 2 comma 5 somewhere here. So this is the radius of the circle, which is r. Let's say r. We assume it to be r because it is an unknown quantity that we have to determine. And the center of this circle lies at 2 comma 5. Okay. So now the question says this circle intersects this given circle C at exactly 2 points. Now what is the concept here? Let us understand the concept first. So if we have, let's say, two circles like this, it is C1 and it is C2, let's say. Then let's assume the radius of this C1 is R1 and the radius of this circle C2 is R2. So we can say if C1 and C2 touch each other internally, then C1 C2 must be equal to R1 minus R2 magnitude. And if C1 and C2 touch each other externally, then C1 C2 is equal to R1 plus R2. Now what is C1 C2? C1 C2 is the distance between their centers. So these are the points. Now if the two circles intersect each other at exactly 2 points, then let us say this as point 3, which is if C1 and C2 intersect each other, then each other at 2 points, then this C1 C2, which is the distance between their centers, should lie in the range R1 minus R2 modulus and R1 plus R2. So this is the main concept that we have to apply to solve this question. That means the radius of this circle is 2 units. So we can say the distance between their center is root under. So distance between their centers is d. It is 4 square plus 3 square. So 5. So we can say this d must lie between modulus of r minus 2 and r plus 2. So d is 5. That means r minus 2 modulus should be less than 5 and less than r plus 2. So now there are two inequalities to solve. We solve each part separately. So if we solve this part, r minus 2 should lie in the open interval minus 5 to 5. That means r should lie in the open interval minus 3 to, this will be 7. Now also r should be greater than 0 because r is the radius of this circle, and also this circle is not a point circle because the circle intersects this given circle C at exactly 2 points. So r should be greater than 0. This is our criteria 1, this is our criteria 2, and there is this criteria which is r plus 2 should be greater than 5. That means r should be greater than 3. So this is our criteria number 3. That means our answer will be the intersection of all three criterions. So our answer will be R belongs to open interval 3 to 7. So we can clearly say this 3 is our alpha and 7 is our beta. So 3 beta minus 2 alpha, which is 3 times 7 minus 2 times this is 3. That means 21 minus 6, that is 50. So option 4 will be the correct option in this case.